Hello everyone. My name is Juan Bernabe Moreno. I'm the Chief Data Officer of E.ON, and I'm gonna talk today about responsible AI for everyone. I'm also a fellow researcher at the University of Oxford for responsible AI. That's why I'm so passionate about this topic. I boiled the topic down to 3 questions, which to me are really relevant for everybody when it comes down to responsible AI, right? Why do we need ethics in AI? What has been done so far in this area? Where are the gaps? Let's start with understanding what artificial intelligence is. Artificial intelligence can be defined in several ways. That's the one that works for me, right? AI is a set of techniques that enable us to find answers to questions we couldn't answer before just with the data we have, right? Based on the data. The most important technique in AI to me is like machine learning. We need to understand how machine learning works because machine learning is the key to these ethical questions and to this ethical debate, right? Unlike traditional software, where you have data and rules as an input, and you apply the rules and you get answers, in machine learning it works in a different way. In machine learning, you get data and answers as an input, and your system learns the rules, the behavior, the logic, right? That's the learning aspect. Everything can be dissected into this process. You start with a problem, so you define your problem. Then you look after the data. So you do the data gathering, you prepare the data, feature engineering, do you have the right features? You extract more features, and then you go and you select your model, your algorithm to learn. And you tune the parameters for this algorithm, and then you evaluate. You see if you can reproduce the answers with the rules you learn, right? And then you deploy it and you consume it, you use it live in a productive environment, and with the time you need to retrain and refresh it. So you move from problem to answers with the cost, everything costs something, using data and training your model. Why it's important? Because we are going to be mapping ethical issues to these particular phases. Let's start identifying some examples where AI doesn't work, right? For example, probably everybody knows this one. Using query data, you can detect epidemics like influenza. Researchers have done it with Google data, but they ran into a trap. The model didn't work a particular year, right? And the problem behind that is what we call data hubris. It's thinking that you can solve each and every problem with data and with machine learning, with enough data and with the machine learning model. Sometimes there are problems that because of the nature, because of you don't have enough data here, or because you didn't evaluate it properly, that you cannot solve with these techniques. Yet you can create false answers. Next one. Probably you know where I'm coming from here. Most of our history, we couldn't think of anything but a white swan. The problem is like when Thomas Cook discovered Australia, this assumption was wrong, was invalidated, because you started seeing black swans. Now, if we take the same example into a machine learning software, for example, the one that you train to predict some diseases, it might be that the data that you train the model on, they are not reflecting the new data that you see, the same behavior, the new data. So you need a mechanism to manage the aging of the data so that changing data is not a problem. It's not compromising your model. As you can see here, the mapping is there. Next one, that's a typical one. Google and others, they are creating models, general purpose models, to tag images, to understand the semantics of the images. And for that, for example, in this case, it's very clear. You have a great ape, a gorilla, mammals, so you have a different tags. The problem is like when you apply that to, let's say, to Google Pictures, Google Photos, then you end up having situations where people, black people, they are tagged as gorillas. Again, it's not designed to behave like that. It's lack of precision. It's the proper testing of the algorithm has not taken place in the proper way, and you end up having that. But that's a racist. That's a completely racist behavior by the system. And the problem probably is here. Probably you might have missing data, and you might not have evaluating that properly. But it happened, and it's going to happen in the future as well. Next one, there's another one that I like. You might what you see there is basically a turtle, right? And machine learning models identify that as a mud turtle. Now you can, while keeping the same shape and keeping the same meaning for the human eye, you can train a model so that you trick your AI using adversarial attacks, so that the turtle is identified as a weapon, as a rifle, right? So again, that's a misuse of machine learning, but it can't happen. There's a risk there. Again, it's a lack of accuracy in the end of the day, but it can happen, and we need to look after that. Next one, can we use pictures to identify criminals or to predict if somebody is likely to be a criminal? These guys here, they did that. Of course, that's something ridiculous. We shouldn't have done it, because you cannot solve this problem with that. And they came up to conclusions like the upper lip curvature is on average 23% larger for criminals, which is not sustained as a nonsense. So in this case, it's the wrong problem. The problem, right? You don't solve this problem with pictures of people. And but again, it's something that needs to be tackled properly. Which problems you solve? Let's talk about bias a bit. The fact that good-looking people are more successful, for example. But let's think about that. Is it a problem with the algorithm, or is it a bias that we might have? Because the algorithm is living out of the data that we feed into, right? Do we make good-looking people more successful without talking about AI? And if AI is trained with this data that we created, because data come from somewhere, right? Is the algorithm exhibiting this behavior? So we talk about a bias here. And there are many biases. For example, the more we personalize, for example, in the advertising space, the more we take the risk of discriminating. If we personalize using kind of ethical attributes like gender, race, and so on, we might jump into traps, like Facebook did here and many others, right? You end up having racist algorithms. If you use the race as an input, then some rules, they might be based on this input. Nothing wrong about the algorithm, but the data is wrong, the data is biased, and the behavior and the result is biased as well. Yeah. You see here mapped. But sometimes you don't even need an algorithm. Let's take this chart. Female representation on boards of top 30 listed companies. You have Germany with 12.1%. Right? Now, if you go to google.de and you search for CEO, you get 82 faces. Out of them, 10 only are female. Right? So it does not correspond with this stat. And you might say, well, actually, Google is biased. Again, it comes down to the data that we have, right? And if the data is biased, the behavior is also biased. Yeah. Next one is like the bias goes even further down. Our language is biased per se, and our expectation. Let's take the translation problem from a language where the article is neutral for doctor and nurse, like Turkish, how it translated into French and also into English. As you see, male translation for doctors, while you see female translation for nurses. It's a probabilistic thing, but again, that's a bias there. But why are you assuming that? Yeah. Next one, it's like with machine learning, you can have what we call deep fakes. Let me play this one by Obama so that you get to see what I mean.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, Killmonger was right, or Ben Carson is in the sunken place.
So you get the point. But again, using this the same technology, you can manage to bring to life a great artist like Salvador Dali, like in a museum in Florida. It is the case, right? You get to see Salvador Dali.
Greetings. I am Salvador Felipe Jacinto Dali y Domenech.
So it's a bad thing if used wrongly. It's a good thing if used properly. Again, a matter for debate. The problem might be wrong, so you shouldn't be having the technology to create deep fakes. But if you did, then you can do a lot of good things as well. So that's the debate. Let's have a look at what has been done so far to tackle that. We witnessed a lot of attempt to develop AI strategies, for example, in many countries. And these countries, they all have a section or many sections for ethics. The problem here is like the lack of consistency and the lack of consensus sometimes. But what you see there is like the appetite for regulating or for providing guidelines for ethical behavior in the AI space is there. The paper called The Ethics of AI Ethics by Hagendorf this year shows us kind of the top attempts of the top code of ethics and code of conduct there, and which kind of issues they address: privacy protection, accountability, fairness. And this picture shows very well that they are very different from each other. They address different things, different issues. They are not complete, none of them. And I'm sure that if we analyze them a bit further, they might even be sometimes contradicting. Right? So it gives you a glimpse of what's been done. But apart from guidelines and ethics, technology is also evolving. For example, there's a lot of research related to bias detection and removal. It's not enough, as we are going to see in a minute, but the research community is working on that because it's very, very important. Likewise, huge advance in explainable AI. One of the issues we have also deriving ethical conflicts. We don't understand how these rules are created or how these rules are learned, as we said before. So there are more and more methods trying to explain this black box of creating rules, right? Especially with technologies like deep learning. And it's helping, for sure. And another technology that's helping is privacy, differential privacy, which consists of while you keep your own data or own identifiable information for yourself, you let algorithms be trained with this data without disclosing you. Right? Next one, also we have a lot of research and good methods to detect the deep fakes, but that's a competition. The better we can detect deep fakes, the better deep fakes become. It's like the antivirus problem. Now, where are the gaps that we've seen so far? Problems like fragmentation. Too many versions of code of conduct, code of ethics, less consensus, and sometimes companies are using this AI ethics as a corporate marketing instrument. So you see many variations, and sometimes it's not helping anyone. Second is it's very difficult to regulate. It's very difficult to create guidelines. One example is like facial recognition technology. The EU wanted to kind of put it on hold. Then it came back in Then in July, they decided to put it back in terms of discussing if they should allow for that or not. Okay. Next one is like AI has a tremendous environmental impact. I mean, the CO2 footprint of training a big, complicated general purpose GPT-2 or whatever model, it's equivalent of many cars, or the emissions of many cars over their lifetime. So we need to also to question ourselves if we really need these models. Next one is like bias remains an issue. I mean, you have even claims like people paying other people to identify and spot bias. So it's like it's a claim of crowdsourcing for bias detection. Next one is like when you create autonomous systems with decision power, you don't come around the fact that you need to program ethical behavior, like the famous trolley problem. You need to program in a deterministic way how to act, whom to kill here. And that's something that is very difficult, very controversial, and many code of conducts or code of ethics are not addressing. It remains a debate, it remains a problem. I don't know how it's going to be solved. This is one example of the moral machine, and they try to do it over kind of crowdsourcing. And there are many others, like adoption remains an issue, enforcement, what happens if people don't adhere to the code of ethics. Ethics are seen as add-on, something extra. Sometimes political abuse of AI systems you don't see it very often in code of ethics. So embedded AI-based ranking sometimes also missing in the most of code of ethics. And if you think beyond where we are now, if you think in 10 years time, and if you think that artificial general intelligence is gonna become a thing, then you have different issues like machine consciousness and danger of malevolence, AGI, right? For you, my key takeaway. So ethics in AI matter, but they are really complicated. In addition to the attempts of establishing guidelines, the good thing is like the technology is also keeping up, it's advancing to make AI safer, more explainable, and more robust. What really matters here is like in the end, it comes down to the practitioners, data scientists, also people consuming AI or people defining AI products. They need to take ownership of these ethical questions. And last but not least, something that I see a lot, understanding. People don't understand AI, yet they try to regulate it. It's really important that understanding is there so that you understand how an AI system works, so that you can debate about the ethical consequences. Thank you very much. I hope it was useful, and see you around.